Now, there are over 30 million organic compounds, and so we don't have to memorize 30 million names. We have a systematic way to name them. When we are going through and naming them, we have a parent name. And that parent name is the number of carbons in the longest continuous chain. And that's what we talked about on the previous screencast. So those are those prefixes, meth, F, prop, and so on and so forth. And these are carbons that are in the chain, okay? Now, you're gonna have carbons that are outside of the chain. These are called substituents. So substituents are just carbons not in the main chain, okay? And we name these by adding a YL to the prefix. Well, what do I mean, right? Well, when we, for example, look at methyl, right? And the way that this chart works, or how you look at it, is it's got the main chain over here somewhere past this squiggly line, right? And if there's just one carbon, we know the prefix for one is meth. And so because it's not in the main chain, we add a YL. Ethyl, we add a YL. Propyl, we add a YL. Isopropyl, we add a YL. Isopropyl sort of throws people off. When we look at propyl, that is 3 carbons, 1, 2, 3, right here in a row. And they're attached to the main chain, right? And then those carbons go in a row. If we have the main chain here and you have attachment here, those carbons, those other 2 carbons will branch off, and that's called isopropyl. We can have other substituents that are not just carbon-based. Our most common ones are here. So if it's fluorine, we call it fluoro. Chlorine, we call it chloro. Bromine is bromo. Iodine is iota. NO2 is called nitro. And NH2 a lot of times is called amino. Okay, then we can also have a suffix, and this is the family name. We've already learned that the family name, if it's a saturated hydrocarbon, the family name there is an alkane. It ends in ANY. In the next screencast, we're going to talk about different functional groups, and each of these functional groups has their own suffix based on their family names. And so that can give us a clue as to what other atoms are in the molecules, and that can give us a clue to the reactivity of those molecules. So this is the systematic way that we name these molecules. So let's go through steps on how we go through and name these molecules and look at an example. So for example, let's say I have this molecule, okay? And I always find it really, really helpful to have a highlighter or to be multiple colors. I just think that's really helpful here. So when we come here to highlight, we are going to look at our groups here, and we are going to find the longest carbon chain. So when we find the longest carbon chain, these are carbons that are attached to each other. So for example, I'm going to highlight the longest carbon chain. So the longest carbon chain is here. They are all attached to each other, right like that. Okay, and then we count that longest chain, and that gives us the root name. Now these are all combined with single bonds, so that would be then pentane, right? Pent because there's 5 carbons, A and E because this is an alkane. There's all single bonds there. So now what we need to look at here is this molecule with the CH3 there, and that is got just 1 carbon. It's not in the chain, so we use the prefix meth because there's 1 carbon, and then it's a substituent, so we're going to add the YL because it's not in the chain. So this would be methyl pentane. Now, here's the deal. We could have a methyl that's attached here like it is, or here right? And so, or here, and so we need to figure out a way so that we know where that methyl group is attached in the chain. And what we use to do this is a number. And so you're going to number the longest chain to give the lowest number to any carbon to which a group is attached. So when we do this, you want the methyl group to have the lowest number. So what do I mean by that? Well, if we look and number from this way, from left to right, 1, 2, 3, 4, right? It would be in the 4 position. But if we number from the other way, 1, 2, right, from right to left, that gives us a lower number. It's in that second position. And so that's the number we use, is 2-methylpentane. So you want to keep these numbers where they're the lowest number when you're going through and naming. What do you do if you have more than one branch, right? So we only have one substituent here. What happens if you have more? Well, let's look at some steps there. So for multiple branches, you need to show the location of each branch with numbers. And then for multiple branches of the same type, you're going to modify the name with di, tri, tetra, penta, etc. for, 2, 3, 4, and 5. And then separate the position numbers by commas. You list the multiple branches alphabetically, but you ignore the prefixes. So I want us to look at an example where we do that. So let's look at this molecule. Okay, so when we look at this molecule, and we come in here to highlight the longest chain, that longest chain is right here. So that's our longest continuous chain. When we go in to number that chain and count those carbons, we see there's 1, 2, 3, 4, 5, 6, 7 carbons. And so that's what gives us heptane. They're all single bonds there. Now, we need to figure out the numbers for these substituents. My suggestion is to kind of automatically give you the lowest number is start numbering to the side closest to the substituent. So notice that this side is closer to a substituent than this side, right? We have to go a long way to get to the first substituent. So that lets us know that we need to number here. So 1, 2, 3, 4. Now you could go on and number on if you want, but we don't have any more substituents, so I'm going to stop there because those are the numbers we need to work with. Now, if we look here, these two substituents both have 1 carbon, and so they're going to be our methyl substituents. So we've got a methyl here and a methyl here. And then this substituent here has a carbon in the center with 2 carbons that are branched off. This is an example of that isopropyl group. So when we go through and we think about this, and we put these in alphabetical order, we know that I comes before M in the alphabet. So isopropyl is going to come first. So you put the name and the number, so 4 isopropyl, right? And then you have 2 methyls here. So with those 2 methyls, you're going to give 2 numbers, 2, 3, and then instead of writing methyl twice, you are just going to write dimethyl. I want you to notice a comma goes between the numbers and a dash goes between a number and the name. Okay, so that's what we have there. So this molecule is named 4-isopropyl 2,3-dimethyl heptane. We are going to do more examples of these in class, and of course we will work in groups to name them, but I do have some additional examples on the next slide. So let's come over here and look at these. Now, one of the tricky things about this is that chains aren't necessarily straight. So when you look at this, you may say, oh, look, this has 3 carbons in a line. Well, that's not really the longest chain. So look, the longest chain can go here, down, here, and over. And so that's our longest chain. And that name there's 5 carbons, and so it would be named pentane, right? And then this is our methyl group. It's just got 1 carbon. And when we count, it's 1, 2, 3. It's on the 3rd carbon. So this would be 3-methyl pentane. Now remember, at any stage, you can stop this screencast and work these on your own and then check your work if that's something that you're interested in. Let's go to the next example here. We're looking for the longest chain. Again, you may think that the longest chain is right here in a line with 4 carbons, but that's not correct. So you have to kind of look all around, and the longest chain goes here all the way down and over. That's going to give us the most carbons in a line. And when we count those carbons, we end up with 6 carbons. So the name of that molecule, the parent name is hexane. Now we need to look at our 2 substituents. So we have a substituent here with 2 carbons that gives us the prefix eth, and so that substituent would be ethyl. And then we look here, right, and that's our methyl substituent again. When we look at this and we count from the side closest to those substituents. So 1, 2, 3. Both of those are in the 3rd position. So we need to put these in alphabetical order. E comes before M. So this would be 3-ethyl dash 3-methyl hexane. And so that's the name of that particular structure. Let's come down here and look at this one. Here is your longest chain, right? And it is really nice. It's straight across. It's not winding around anywhere. So when we name that, there's 8 carbons there. So it would be octane. Then we need to look at our substituents. We have a substituent here, and then we've got a substituent here and a substituent here. These all are methyls, okay? And so this is a situation where you get to use trimethyl, but you need to give a number for each one. So 1, 2, 3, 4. So the way that we would name this would be 2, 4, 4 trimethyl. So the prefix here is 3. If you have a prefix for 3, you need to have 3 numbers. If you have a prefix 2, you need to have 2 numbers. Even though these are at the same carbon, you have to write that number twice. That's just part of the rules for naming. All right. And then our last example here, right? This is our longest chain. That gives us 6, so that would be hexane. We have a methyl here. It's in the 2 position, so this would be 2-methyl hexane. And again, we will work more of these examples in class. So there's kind of 2 ways that you can be asked to do a problem like this. You can be given the structure and asked to name it. You can also be asked to draw the structure. So I have 2 problems here where you draw a condensed structural formula for 3-ethyl 2-methyl hexane. Now, when I start to do these, I start with the parent hydrocarbon chain first, and I just draw the carbons. So when I do this, right, I have a carbon, carbon, 1, 2, 3, 4, 5, 6. So I have my 6 carbons, right? And then I'll count 1, 2, 3, and then put in my ethyl, right? And my ethyl group, I know, is going to be a CH2, CH3. And then in the second position, there's a methyl, which is a CH3 here. Now at this stage, I'll go in and add in my hydrogens. And I do this again based on the fact that carbon needs 4 bonds. So I evaluate how many bonds each of these carbons have. They need 4, and then fill in with hydrogens to get them to where they have 4. So for example, this carbon only has 1 attachment. So then it needs 3 attachments from hydrogen. This carbon only has Has 3 attachments, so it only needs 1. This one only needs 1. This one needs 2. This one needs 2. And this one needs 3. Now that's the expanded structure. This asks for the condensed structure. So we would go CH3, CH, CH3, CH, CH2, CH3, CH2, CH2, CH3. And so that would be the answer to this particular problem. This asks us to draw the condensed structural formula for 3-isopropyl hexane. Again, I like to start by drawing on my carbons. So there's 6 carbons. 1, 2, 3, 4, 5, 6. In the 3 position, I want to put an isopropyl group. An isopropyl group is a carbon that has a two CH3 groups that are attached. So it's attached to the parent chain through the middle carbon. Now again, I'm going to go in and fill in those hydrogens to take up the space so that every carbon has 4 bonds. So 4 is the big number here. And so now we're going to go through and write our condensed structure. And you really want to make sure your lines aren't kind of wandering around. You want to make sure that you're showing that it's the carbons that are connected, right? So what do I mean by that? You'll notice that this line goes from here to the carbon here. When you're doing this, you don't want it to look like this. Right? Because we're reading that carbon is attached to the hydrogen. So don't do this, but do watch kind of those lines. Make sure you're showing your carbons are attached. Well, maybe the burning question in your heart is, hey, Dr. Pierce, what about cycloalkanes? We talked about those in the last screencast. And you named much in the same way. There's a little bit of one exception here. So when there are 2 or more groups that are attached to a cycloalkane, you number the ring with the first carbon that's attached to the first group alphabetically. So basically, if you have just one, if there is just one substituent for a ring, you need no number, okay? We don't need a number. But if there's 2 substituents, then you need to give the name, and you want to give them the lowest number. So you would count from 1 to 2. You would not count 1, 2, 3, 4, 5. So the answer here will be 1,2-dimethylcyclopentane. We have 2 substituents here. One is a chloro group and one is a methyl group. In the rings, right, you want to start numbering from the group that's the lowest alphabetically. So chloro is the lowest, 1, 2, 3. So it'd be 1-chloro, 3-methylcyclopentane. So let's do an example. So when we come here to do an example, and I believe yours will be on the next page. So for whatever reason, mine didn't come in on the next page. But so flip to the next slide. You should be able to see it there. We have some groups that look like this. Okay. When we look at this group, we see that it's a cyclopentane. And there's 1 carbon that's off of it, so it would be a methyl. Cyclopentane with no number. We look at the other example. Put a CH3 there and a CH3 there. So when we come here and count, 1, 2, 3, this would be 1, 3. There are 2 CHs, 3, so that'd be dimethyl cyclopentane. All right, so that ends our screencast for today. Again, we will work more examples in class. And as always, if you have any questions, please, please, please stop by my office hours.